Good. 6.1 and 6.2 will be the law of sines, and then law of cosines. Then we get into some vector stuff. So one of the things that happens in chapter 6 is you guys start to feel a little bit more comfortable with this material because you've seen the triangle stuff before. It seems pretty easy, but I'm just going to warn you, make sure you're digging into some more homework. We do have a worksheet that will come out next week that will help you kind of review the stuff. But over the weekend, maybe go back and you guys could already start practicing some of the law of cosine stuff that you learned last year. So remember, law of sines, we're using this to solve what's called an oblique triangle. What we're talking about is a triangle that's not 90 degrees. If it is 90 degrees, we still go all the way back to like the SOHCAHTOA stuff. Law of sines we should only use it when we're talking about knowing two angles and any side. Two angles and any side. So angle, angle, side, angle. That's when law of sines is really nice to use. We have to be more careful here, so put an asterisk there. The reason why you can't use the SSA or ASS congruence rule in geometry is because it allows for what's called the ambiguous case. I'm going to try and I'll try and draw something so you can. So let's go back to page. See if I can get this to work. Let's do this color. Okay. So let's say you don't have to worry about this, but let's say I send you home with sticks that are 16, 12, and let's go, something like a 30-degree angle. Okay? I would assume most of you would go home tonight and you would set a protractor on the table. So you'd set your protractor on the table and you would mark, you would kind of know where that 30-degree mark is. And you would take your first stick and you'd bring it over and lay it on that 30-degree angle. And then you would take your other stick, the 12, whatever, bring it over here. Where's mine? There we go.
We use our imaginations.
So you bring that over there. I got it. You just need to tilt this one a little bit.
Look to the back. Nice. You got it. Nailed it.
See, I got to get it on my 30-degree mark.
Wow. Really impressed.
Okay.
Nice. Beautiful.
Okay, so that's probably how you guys would build the triangle. And then what you do is along the table, you put your third and final stick of the triangle down and cut it to the length that you need. Okay? But what can happen and what the ambiguous case tells us is that does not guarantee that we all have the same triangle. Because what can happen is this blue, which would be like the 12-meter or 12-inch side, can actually rotate and be that triangle, right? Yeah. So you can visualize that? So what would happen is you would put, these 2 points would be fixed together like a hinge, and so the visual is that maybe that was the first spot where it hit, and now we have a second spot where it can hit. So there are two different triangles, and that's where that ambiguous case is happening. And so in pre-calc, we spend a little bit more time talking about when that can happen, and if it does occur, it doesn't mean it's going to happen every time, but when it does occur, you have to be able to know how to figure it out. Okay? So that is why you need to be aware of what the two sides and an angle opposite one of them, which is called the side-side angle. That's the ambiguous case, or the possibility of the ambiguous case. You have to be very careful. The law of signs, you do not use 3 of them at a time. You only use 2 of them. So maybe you would go like this with those 2, or maybe go like this. Depending on how your Algebra 2 teacher taught you, you may put the sides on top and angles on the bottom. You may put the angles on the bottom and angles on top and the sides on the bottom. Or the way I will always do it, I always put my variable in the top left corner. Okay? It just makes it a little, if you always do it the same way every time, you're probably going to be a person that cross multiplies and then divide off what you don't need. So draw it, just in these problems, we just want to draw a triangle. I tend to just go A, B, C. I don't worry about the shape of the triangle right now. The problem has nothing to do with the shape. More important that you get stuff located in the right spot. So big letters indicate angles, or in this case they said angle B is 20. Angle C is 31. And then little b, which would be located right here, little b, right, opposite the big B, is 210. They're asking us to find everything else. So they want us to find little a, little c, and angle A. So what can we do first?
Can't we do C? Yeah, can't we find the side of C?
Sure. But let's do this first. My suggestion is whenever you are working with triangles, whether you need it or not, if you know 2 angles, just find the third one, just in case it would kind of spark something for you. So angle A will be 180 minus 20 plus 31. What are we getting? 129 degrees. Whether I need it or not, I'm finding it. Now, do you have to write that little formula down? Yes, you do. Because that indicates to me what you're doing. You're not using the law of sines or law of cosines to find that angle. You are using the 180 minus the sum. Okay. What's next? Let's find... We can go ahead and find side C. So I'm going to put side C on top. In the next 2 days with the lectures, we're going to hear the term opposite. And what that means is that like angle A touches side C and touches side B. It does not touch side A, right? These two sides come into angle A. So opposite is the angle that does not touch the side over there, right? A lot of you, when you say opposite, it just visually works for you, but sometimes it doesn't. So C goes along with angle 31. So I'm putting the side in the top left corner. So I put the sine of its angle underneath it. To work with the law of sines, I'm just going to circle it and then erase it quick. You have to have what I call an angle side pair. You have to know an angle and its partner side, or a side and its partner angle. So we're going to use those two. I'm going to put the 210 on top over the sine of the 20 degrees. So what you're doing is you're setting up a proportion. If you put the sides on top, they both have to be on top and the angle's on the bottom. Once you do that, once you write that down, I do not need you to show me the work because most of you are going to the calculator. So let's go to the calculator. We have degrees, right? So make sure your calculator is in that degree mode. So, over on the right-hand side, I had 210 divided by the sine of 20 degrees. I'm going to go ahead and do that. Now, when you look at it, over here we have A over the sine of 31, right? How do you get rid of that sine of 31? You're dividing by the sine of 31. So what do? You have to multiply it to get rid of it. So I'll take that answer and multiply by the sine of 31. So I'm getting 316.23. 316.23. People agree with that?
Yeah.
So again, I don't need to have you show me the work, but we took the sine of 31 here, sine of 31 there, and what happened was C was by itself. And we're doing all of that on the calculator. All I'm asking you to do is write down the formula or the equation. Okay? Questions? No? So, now that little a is done, or excuse me, little c we found, now we have to find little a. So we're going to put little a on top of the sine of 129. What am I going to use for the other side? Could I use my side C, angle C? You probably have heard a teacher already tell you don't do that, right? Why? Could be wrong. We found it. So if it's wrong and we use it again in the same problem, we're going to be wrong again. So it's a lot better to go back to the 210, the B stuff, right? So 210 is the side, so that's going on top. Sine of 20 on the bottom. Go ahead and tell me what it's going to be, please. What? 477? Point
16.
477.17.
Whatever. Close enough. Okay? So, we found the rest of the triangle. So typically we give you 3 parts of the triangle, and the directions are basically good so you find all the missing parts.